Okay, this video we go over example 13.1 from the book, which the homework is based on extending this problem. This is a product mix problem where we're making two types of computers. We're making a basic computer and an XP computer. And the data is given is that the hours to assemble a basic and an XP, these are the per unit hours to assemble one, and then after you assemble them, you test them. We also are giving how many hours available in assembly and testing. We're also giving what it cost us in labor hours. So we use 5 hours of assembly and 6 hours of assembly for these two, but that's per unit. The cost per labor hour is $11 for assembly and 15 hours for testing. We know that we can sell the basic for $300. We can sell the XP for $450. The cost of the components is $150 and $225 for the XP. So, and the other thing that we're given is the maximum number that we can sell of the base is 600 and 1200 of the XP. Okay, so how do we set this up to do an optimization model? The first thing we've got is that we have to have decision variables representing how many of the basic and how many of the XP. So in this problem we have two decision variables. Once we have those, then we can calculate the hours used. The hours used is the number made against the assembly hours, and then the number made against the testing hours to give me a total hours used, and then I can write a constraint saying that these must be less than these and these must be less than these. My labor cost is my hours used multiplied by $11 an hour. Same thing there. Those can get dropped down into these two here. You get there two different ways. Then so you can calculate labor costs there, or you can also calculate it on a per unit basis like this. So you could either use this labor cost, total labor cost, or you could have used it this way. It doesn't make any difference. I just wanted to show you could do it two different ways. Our revenue is based on how many we make multiplied by the selling price. The component cost is how many we make against the component cost. And then I can do labor cost either way. And then my total profit then becomes the revenue minus my component cost minus my labor cost. That's what I'm trying to make really big. And then the last thing is I've got to make sure that the number that I make is less than my maximum sales. So in Solver, I've already set this up for you. What I'm trying to do is maximize my profit by changing my number made of each, and then I've got two sets of constraints. Let me delete those and redo those. One of them is that the hours used, and I'm going to do this in set format, have to be less than or equal to hours available. And then the other one is that the number that I sell has to be less than or equal to my max sales. Don't forget to turn this into a linear model or use the simplex engine. Keep that checked, hit solve, and that's the answer I'm getting. The answer says the optimal thing to do is make 560 basic, 1200 XP. I've maxed out all of my assembly hours. I have not used my testing hours yet. I've maxed out the number of XPs. I have not maxed out the number of basics that I could sell. And this is my optimal profit. Thanks.